This is a pretty daunting problem, but let's take a moment to understand what a square root is. I think if we do that, the steps that come next are going to be pretty easy for you. So what is the square root of a value? We all know the square root of 4 is 2, because when we square 2, we get to 4. That's what a square root is. It's the value that when you square it takes you to your original value. So let's deconstruct r a bit. Let's take it one step at a time. 2 to the 16th, what can we square to get to 2 to the 16th? That would be 2 to the 8th, right? Because 2 to the 8th times 2 to the 8th would take us to 2 to the 16th. And likewise, what can we square to get to 5 to the 34th? Well, that should be 5 to the 17th, because if we square that, 5 to the 17th times 5 to the 17th is 5 to the 34th. And finally, what do we have to square to get to n to the 50th? That would be n to the 25th, because n to the 25th times n to the 25th is n to the 50th. In other words, the square root of r should be 2 to the 8th times 5 to the 17th times n to the 25th. That's the value of quantity A. As a next step, I'm going to simplify this information a little bit to make the problem just one hair easier for you. Remember, if your quantities are positive, you can cross-multiply them to make the comparison easier. And we know that the square root of r is the same thing as the square root of r over 1. So if I cross-multiply these quantities, notice that we end up with 10 times 2 to the 8th times 5 to the 17th times n to the 25th, and that's being compared to r. Well, what is 10? 10 is 2 times 5, right? And if I multiply that with the square root of r, we get 2 to the 9th times 5 to the 18th times n to the 25th. And we can see that's clearly smaller than quantity b, which is 2 to the 16th times 5 to the 34th times n to the 50th. If that's the case, b is clearly bigger than a. And remember, anytime that b is bigger than a, that means your correct answer is b.